Okay, today we are looking at section 3.7. In 3.7, we're going to be talking about variation and how to solve variation problems. Okay, when you have a variation problem, you always have a K. That is your constant of proportionality. Okay, and once you find that value for a problem, for that problem, it does not change. That's going to become important here in a little bit. Okay, so when it's direct variation, you take your constant of proportionality times x. Okay, when it's inverse variation, you're going to divide your k by your x, and you don't have to use x and y. When I do a problem, I use the variables that represent what's in the problem. Okay, so the first thing you're going to do is you're going to write an equation, and then they're going to give you the values for x and y or whatever variables you choose so that you can find k. And then you can put k into the equation, and then it's going to ask you a final question. Let's look at an example here. Okay, the volume of blood B in a person's body varies directly as body weight W. Okay, let's stop there. B varies means I put equals K automatically. Directly means I multiply by W, the person's weight. Okay? A person who weighs 160 pounds has 5 quarts of blood. Weight is 160, so I know that's my W, and I don't have to wonder if it's X and Y, which one is which. Has 5 quarts of blood. How am I going to solve that equation for K? I'm going to divide both sides by 160. So that K equals 5 over 160. Now, both of those are divisible by 5, so I'm going to reduce it to 1 over 32. So now my equation can become B equals 1 over 32 W. Okay? Because I can substitute that value for W into the equation. Now what does it say? Estimate the quarts of blood. So what is B? That's what I'm looking for. If I weigh 200 pounds. And if I punch that into the calculator, that person has 6.25 quarts of blood. Let's look at another equation. Okay, the distance S that a body falls from rest varies directly as the square of T. So first, from that sentence, write your equation. S varies directly as the square of T, or T squared. Okay? So, if a skydiver falls 64 feet in 2 seconds, so the seconds is 2, and the distance they fall is 64. Square my 2, divide both sides by 4, and I get K equals 16. So now I can rewrite my equation as 16 T squared. Excuse me. So how far will they fall in 4.5 seconds? So remember, the time is your T. So what do I get if I do 16 times 4.5 squared. And that gives me 388 feet that they will fall in that 4.5 seconds. Okay? Let's look at the next one. When you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. This decrease of pressure causes the volume of the gas in the can to increase. Because the gas needs more room than is provided in the can, it expands in spray form through the small hole near the valve. That's just giving you information about what's happening, but it really hasn't told us anything about how it varies yet, okay? In general, if the temperature is constant, the pressure of gas in a container varies inversely as the volume of the container, okay? So the pressure varies inversely as the volume. The pressure of gas in a container whose volume is 8 is 12 pounds. So for a volume of 8, the pressure is 12. So in this case, to find K, I've got to multiply both sides by 8. So I get K equals 96. So P equals 96 over V. Okay, so if the sample expands to a volume of 22, what is the pressure? So if the volume is 22, what is the pressure? So what is 96 divided by 22? 4.36, and it would be pounds per square inch. Okay. Oops, volume is cubic inches, so it would be inches cubed. Sorry about that. No, I was right to begin with. I'm bad. I'm not finding volume. Okay, pounds per inch squared. You don't necessarily have to put units on there, but I do. Okay?